In Dan Larimer's proposed version of the Constitution, the intent of code is law version, he states that all parties are responsible for auditing the code and the Ricardian contract before use. Basically, the bytemaster is putting the onus on the individual user to decide for themselves which smart contracts they choose to interact with versus which ones they don't. But in a world where the typical user is not technical enough to audit smart contract code, how do we expect users to make intelligent assessments as to the risk involved with a given smart contract? Because on the road to mass adoption, it's simply not practical to expect every end user to code review every smart contract they'll be interacting with. In this special edition episode, we'd like to explore how tokenomics could be used to solve this problem, with a hypothetical new dApp that would assess the risk of smart contracts. Welcome to this special edition episode of EOS Weekly. We've got a great episode for you today. If you haven't done so already, please help us out by subscribing to our channel and hitting the like button. Thank you, and let's get into this week's episode. There's three issues facing dApps and dApp users today that are interrelated. Issues that need to be addressed in order for EOS to achieve mass adoption. And those three issues are: 1. The onus is on the individual smart contract user. What the bytemaster is proposing in his version of the Constitution is that people need to take responsibility for their own actions and so need to be aware of the risk level and integrity of the smart contracts that they interact with. 2. The end user's skills and time. We believe it's pretty much common sense that the typical smart contract user will be ill-equipped to assess smart contract code. They just don't have the technical knowledge to do code reviews, nor do they have the time. 3. Smart contracts are bleeding-edge technology. By this we mean smart contracts are a new technology, and they're evolving quickly. Their usage is constantly expanding into new industries and uncharted territory. This is a good thing for third-generation blockchains like EOS, which is built for this type of thing. But using technology on the bleeding edge like this is inherently risky. For example, you're not going to find a smart contract developer with 20 years of experience. It's just too new. We're all learning as we go. When you combine these three things together, we've got a bit of a problem, right? The question then becomes, how do you bridge the gap? How do you give the end user a view as to how risky a given smart contract is to interact with? For example, wouldn't it be nice if you could see a gauge like this that would tell you how risky a given smart contract is before you interact with it? Something the end user could see and immediately know what sort of risk they're dealing with without having to go in and review the code themselves, which is just not practical. What we're getting at is a hypothetical dApp that would combine these three elements together: smart contract risk assessment, bug bounty, and a library of flawed smart contracts, what's wrong with them and how they were fixed. Combining these into a single tokenized system with incentives set up the right way so as to produce this smart contract risk gauge as its primary output. A risk gauge for any smart contract that dApp developers choose to submit when participating in our hypothetical system. We've got a rough draft of how such a system could be designed, with the tokenomics set up in such a way that it would align incentives to produce this risk gauge. And that's what we'd like to explore with you today in this episode. Here's the general premise of what we're proposing: that dApp developers could choose to submit a smart contract / Ricardian contract pair to our hypothetical dApp. And actually, before we go on, let's give our theoretical dApp a name. So we're going to call it Vouch Monkey. So Vouch Monkey would enable dApps to submit smart / Ricardian contract pairs to it for review. And technical people with experience in smart contract development, would log into Vouch Monkey and be able to see all the smart contracts submitted to it for review. They could then, based on things like the size of the bounty or their interest in a certain dApp, choose certain smart contracts to review. And once they've zoomed in on one, they'd look at the contract closely to determine whether there are any flaws in the smart or Ricardian contract. Are there any bugs in the smart contract that could cause it to behave in unintended ways? Does a smart contract do any more or less than what is described in the Ricardian? Is there a mismatch between the two, for example? If everything checks out, the peer review person would add a stamp of approval to the smart Ricardian pair. Basically, they would vouch for this smart contract, saying all is well with it. Multiple people could review the same smart contract. In fact, the more the merrier. Or, if a flaw is found, the reviewer would submit a report to the dApp development team describing the bug or the discrepancy between the smart and Ricardian contracts. And this flaw report would have to remain hidden long enough to allow the dApp owner to take action and address the issue. After all, we wouldn't want bad actors to be able to monitor this system for vulnerabilities to exploit. The more people who have put their stamp of approval on the smart contract, and the longer it has been out for public review without a flaw being reported, the less risky the smart contract would be deemed to be. Now, the question becomes, is there a token scheme that could be used? A set of simple rules for the behavior of tokens that would encourage technical smart contract developers to participate in this system. We'd want people to be encouraged to review newly submitted smart contracts and basically put some money where their mouth is, to say to everyone, yes, I have reviewed this smart contract, and it does exactly what the Ricardian contract intends it to do. This is approved. It is safe. Or if they did find an issue with it, they would be incentivized to write up a bug report describing the vulnerability or the discrepancy between the two, and submit the report to the dApp team to take action, which would all be done through this dApp. Here's the token mechanics we came up with that we think would cause this type of system to work. 1. A dApp would submit a smart contract together with the corresponding Ricardian contract and add a bounty to it. The higher the bounty, the more eyes they're going to get on this, the more approvers or the more likely that a flaw would be uncovered. So the bounty is important. 2, anyone can review and approve the contracts. And when you approve, you stake any amount of tokens you want to the smart contract. Those tokens are staked for 30 days. 3, you earn a 5% fee for staking those tokens for 30 days. That's 5% of the number of tokens the approver staked. That fee is paid out of the bounty. 4, when a flaw is found, the person who found the flaw writes up a report describing what they found. That flaw and the report are kept hidden for 3 days while the dApp team reviews it. 5, if the dApp confirms it's a valid flaw, the person who found it gets paid the bounty, whatever's remaining of it, plus all the staked tokens. Those approvers who staked their tokens against a flawed contract lose them. 6, if the bounty is running low because of so many people approving a given contract, the dApp can choose to replenish it at any time to keep the momentum going. Or if they feel the contract is now safe and doesn't need any more eyes on it, they can let it expire. So those are the token mechanics of our system here. Now, let's go through a quick example to make it more clear. So let's say that EvaCoop, the ride-sharing dApp built on EOS, which was actually our featured project of the week a few weeks ago. Let's say EvaCoop wants to get a contract reviewed and assessed for its risk level. They would log into Vouch Monkey and submit the smart contract together with its corresponding Ricardian contract and put a bounty of, let's say, 1,000 Vouch Monkey tokens, that's VMTs, onto this contract pair. This shows up on the Vouch Monkey dashboard, and the reviewers take notice. The first reviewer comes in, named William Shatner, and he finds no issues and approves this with a 100 token voucher. 5% of 100 is 5 tokens, so he gets a 5 token fee, and this comes out of the bounty. So you see the bounty has gone down from 1,000 to 995. The 100 tokens are now staked for 30 days. After 30 days, those tokens will return to Shatner's account. The next day, Leonard Nimoy comes in and also approves, staking 200 tokens and claiming a 5% fee of 200, or 10 tokens. Scotty Beamer comes in the next day and approves, staking 100 tokens. Shatner's staking is now a few days old, So he only has 28 more days before his staked tokens are back in his account. But uh-oh, what happened here? Jean-Luc Picard found something that the others missed. He writes up a bug report and submits it to EvaCoop. If EvaCoop finds this is a valid issue, they acknowledge Jean-Luc Picard's findings, and he is rewarded the remaining bounty plus all the staked tokens. So he'd get 1,380 tokens in this case. If EvaCoop refuted the flaw, saying that it's not a valid flaw, the report would be made public, that Jean-Luc Picard reported, that would be made public for all to see, and the approvals would continue on going as if that didn't happen. Now, this Vouch Monkey dApp would draw in other types of reviewers besides the true person who really knows his or her smart contracts, namely gamblers. Gamblers who know nothing about smart contracts would probably be drawn in to try to profit off this system. But that's okay. Gamblers would be totally welcome. All that gamblers would end up doing in this type of system would be to sweeten up the honeypot for those who actually know what they're doing. The true smart contract developer would have a huge advantage over the gamblers and would end up taking their money, taking their tokens, like a real poker player playing with novices. So gamblers would be fully welcome if they wanted to try their hand at this system here. Now, let's say a bunch of people vouch for EvaCoop's smart contract, staking their tokens against it, but then a hacker finds a vulnerability in this smart contract and exploits it. Essentially, the hacker would have found something that none of the people here vouching for it found. So let's say the hacker exploits the vulnerability, damaging either EvaCoop's customers or EvaCoop themselves. In this case, if EvaCoop so desired, they could submit the flaw themselves and claim the staked tokens to use in compensating anyone damaged by the exploit. They would be fully in their rights to do this. After all, the approvers here are earning fees off of a flawed contract, and they missed the flaw, and they were profiting from the bounty that EvaCoop supplied in the first place. Now, there's only one issue with our current Vouch Monkey logic that would cause it to be a bit suboptimal. And it has to do with this part here when the reviewer is choosing from a list of smart contracts to review. How do you encourage the reviewer to be one of the first reviewers on a newly submitted contract? Because when no one else has approved it yet, it's going to be much more risky to stake against this one as opposed to one like this where several have already reviewed and approved. It's not really fair that the first person to approve a smart contract, sticking their neck out on the line, and say the sixth person down here who is jumping on the bandwagon, get paid the same amount. We need to tweak things a bit to make it advantageous for people to be the early reviewers of newly submitted contracts. And we do that by making a slight change to this rule here. Instead of making it a flat 5% fee that all approvers get paid, we need to use more of a Z-curve like this, where the first approvers would get upwards of something like 10%, and the later approvers would get a smaller and smaller percentage fee, going into the long tail. This would make the bounty last longer as well. So we'll reword the third item here to say that it is a graduated fee instead of a flat 5% fee. Going back to our example, the first and sixth people have staked the same amount, but the first approver gets a higher percentage fee, which they rightfully deserve for being an early approver. Now our set of rules ought to align incentives correctly. And Vouch Monkey would have some pretty good data available to output a risk gauge like the one we described earlier. Basically, the more people who have approved a given contract and the more tokens they have staked against it, the less risky that contract will be deemed to be. Vouch Monkey could then output a little widget like this that dApps could integrate inside their dApp, showing risk level right in the same vicinity of the button where the end user is about to submit a smart contract transaction. Just to clarify, we at EOS Weekly are not planning to build Vouch Monkey. We just wanted to show you how something like this might be built in this new tokenized world that the EOS blockchain is making possible. In fact, if anyone wants to build a dApp like this using the logic we described here, please reach out to us and we'll help you promote it on our channel. That's it for this week's episode. Thanks so much to all our viewers who are helping to make this channel a success. If you haven't subscribed yet, please do so now. We'll help you stay current on EOS as this revolution unfolds. Thanks, and we'll see you next week right here on EOS Weekly.